All right, let's start. Hi everyone, thank you for joining. All right, so today will be the last session for this part 2. All right, so in containerization sharing. All right, so this is basically what we went through for the past 4 different weeks. All right, on the first sector, right, we have concept sharing, followed by a hands-on lab. Right, and this is done on this part 1 already, and followed by the sharing for the Linux container in and the WSL. Right, and of course followed by a interesting hands-on lab where we actually learn how to turn on the WSL features and install the Kali Linux and turn on the S window on last week. Right? So this part's done as well. Right? And this week I will share some interesting topic about the local container registry and together with the Azure Kubernetes service. Right? So let's have overview of the summarize of the past few weeks, right? So on the first sector, right, which is this is I think is on the 5th of May, something like that, right? And we actually have a concept sharing. After that, we have a hands-on lab, right? And this is what we're going through on this particular hands-on lab on turning on the containerization capability in the host machine, right? With the features, right? And also the Docker manager application, right? Together with the Docker station, right? And after that, we went through a series of labs steps on how to search for the image, right? And we spin up the container image, right? So this is what we're going through from the first hands-on lab, right? And followed by the week after, right? We'll have the sharing on the Linux container together with the how we actually turn on the Windows subsystem for Linux and how we actually install the Kali Linux, right? And followed by the labs, right? And this is just a summarize of how does the labs is being performed, where we actually turn on the Windows subsystem for Linux. After that, we download the Kali Linux distro, the installer from the Microsoft Store, right? After that, we went through a series of interesting steps to turn on the Kali Linux, right? And how to interact with the Kali Linux S window, right? And last but not least, we actually turn on the seamless mode in Windows 11 together with this Kali Linux. So as you see here, we have 2 different bars, right? The Windows bar actually at the bottom of the screen, and the Kali Linux bar is actually on top of the screen. Right? So this is how both different type of systems actually work seamlessly in the Windows 11 environment by using the Windows subsystem for Linux version 2. Right? So let's carry on for the topic for today. Right? Before that, I have a simple question to ask. All right. So what are the tools that we can use to manage the container? All right. So this is a very simple question. Right? Feel free to share your answer into the chat window. All right. All right. So obviously the answer is all the above. Right? We can use the Docker command to manage the container. We can also use the Windows Admin Center, and of course the Docker desktop program, as well as the Docker doc station. Right? And this is another question, right? And this is very interesting. Right? So can I actually run the Android application in Windows platform? Right? So this is a very interesting question, huh? So can we run the Android application in the Windows system? Right? So the answer is yes, huh? So this is a new subsystem for Windows that is made available, right? As you can see here, this article is updated in 17th of May 2022, right? Talking about the latest update for Windows subsystem for Android, right? By enabling this subsystem, it seems like Windows subsystem for Linux. Once you turn on, you can actually run the Linux distro on top of your Windows, right? So by turning on this Windows subsystem for Android, you are able to download the Android app from the Amazon store. Let me see, if I'm not mistaken, it's an app store from Amazon, Amazon App Store, right? And you can install it and have it running on top of your Windows system, right? Your Windows client, right? In this scenario, is Windows 11, right? So this is something interesting, and I urge you to have a try on it, right? So let's carry on the topics that we're going to show this week, right? First of all, I will do some simple introduction about the Kubernetes service, right? On about what is Kubernetes service and what is Azure Kubernetes service and what is the Azure Kubernetes on the Azure Stack HCI, right? And followed by the topic number 2, where I will talk about the container registry, right? And followed by the how we're actually managing the AKS on the Azure Stack HCI, right, with Azure Arc, right? And I will go through some simple steps on how we actually manage the AKS on HCI, and as well as some installation setting, right? Any questions so far? All right, so let's continue. First of all, we have to have a conceptual understanding of what is Kubernetes. Right? It's an open source system for automating the deployment, the scaling, and the management of the containerized applications. Right? So it groups the container that make up the application into the logical unit for easy management and discovery. Right? So, and before we carry on, I actually got a very simple video that shared about these Kubernetes services. And the video is a little bit long. It's about 8 minutes plus. So we get it started, all right? Let me know whether you can hear the sound.
The other day, my daughter sidled into my office and asked me, "Dearest father, whose knowledge is..."
Can everyone hear the sound from the video?
Yes.
All right. All right. So let's continue. This is a very interesting video, right? All right. Talk about Kubernetes, right? Oh, sorry.
The other day, my daughter sidled into my office and asked me, "Dearest father, whose knowledge is incomparable, what is Kubernetes?" All right, that's a little bit of a paraphrase, but you get the idea. And I responded, "Kubernetes is an open source orchestration system for Docker containers. It handles scheduling onto nodes in a compute cluster and actively manages workloads to ensure that their state matches the user's declared intentions. Using the concepts of labels and pods, it groups the containers which make up an application into logical units for easy management and discovery." And my daughter said to me, "Huh?" And so I give you the illustrated Children's Guide to Kubernetes. Once upon a time, there was an app named Fippy, and she was a simple app. She was written in PHP and had just one page. She lived on a hosting provider, and she shared her environment with scary other apps that she didn't know and didn't care to associate with. She wished she had her own environment, just her and a web server she could call home. An app has an environment that it relies upon to run. For a PHP app, that environment might include a web server, a readable file system, and the PHP engine itself. One day, a kindly whale came along. He suggested that little Phippy might be happier living in a container. And so the app moved, and the container was nice, but it was a little bit like having a fancy living room floating in the middle of the ocean. A container provides an isolated context in which an app, together with its environment, can run. But those isolated containers often need to be managed and connected to the external world. Shared file systems, networking, scheduling, load balancing, and distribution are all challenges. The whale shrugged his shoulders. "Sorry, kid," he said, and disappeared beneath the ocean's surface. But before Phippy could even begin to despair, a captain appeared on the horizon piloting a gigantic ship. The ship was made of dozens of rafts all lashed together, but from the outside, it looked like one giant boat. "Hello there, friend PHP app. My name is Captain Kubi," said the wise old captain. Kubernetes is the Greek word for a ship's captain. We get the words cybernetic and gubernatorial from it. Led by Google, the Kubernetes project focuses on building a robust platform for running thousands of containers in production. "I'm Phippy," said the little app. "Nice to make your acquaintance," said the captain as he slapped a name tag on her. Kubernetes uses labels as name tags to identify things, and it can query based on these labels. Labels are open-ended. You can use them to indicate roles, stability, or other important attributes. Captain Kubi suggested that the app might like to move her container into a pod aboard the ship. Phippy happily moved to Kub's giant boat, and it felt like home. In Kubernetes, a pod represents a runnable unit of work. Usually, you'll run a single container inside of a pod, but for cases where a few containers are tightly coupled, you may opt to run more than one container inside of the same pod. Kubernetes takes on the work of connecting your pod to the network and the rest of the Kubernetes ecosystem. Phippy had some unusual interests. She was really into genetics and sheep, and so she asked the captain, what if I want to clone myself on demand any number of times?" "Well, that's easy," said the captain, and he introduced her to the replication controllers. Replication controllers provide a method for managing an arbitrary number of pods. A replication controller contains a pod template which can be replicated any number of times. Through the replication controller, Kubernetes will manage your pod's lifecycle, including scaling up and down, rolling deployments, and monitoring. For many days and nights, the little app was happy with her pod and happy with her replicas. But only having yourself for company is not all it's cracked up to be, even if it is N copies of yourself. Captain Kubi smiled benevolently. "I have just the thing," he said. No sooner had he spoken than a tunnel opened between Phippy's replication controller and the rest of the ship. With a hearty laugh, Captain Kubi said, "Even when your clones come and go, this tunnel will stay here so you can discover other pods and they can discover you." A service tells the rest of Kubernetes' environment, including other pods and replication controllers, what services your application provides. While pods may come and go, the IP address and ports of your service remain the same, and other applications can find your service through Kubernetes' service discovery. Thanks to the services, Phippy began to explore the rest of the ship. It wasn't long before Phippy met Goldie, and they became the best of friends. One day, Goldie did something extraordinary. She gave Phippy a present. Phippy took one look, and the saddest of sad tears escaped her eyes. "Why are you so sad?" asked Goldie. Oh, I love the present, but I have nowhere to put it, sniffled Phippy. But Goldie knew what to do. Why not put it in a volume? A volume represents a location where containers can access and store information. For the application, the volume appears as part of the local file system. But volumes may be backed by local storage, Ceph, Gluster, Elastic Block Storage, and a number of other storage backends. Phippy loved life aboard Captain Kubi's ship, and she enjoyed the company of her new friends. Every replicated pod of Goldie was equally delightful. But as she thought back to her days on the scary hosted provider, she began to wonder if perhaps she could also have a little privacy. Sounds like what you need, said Captain Kubi, is a namespace. A namespace functions as a grouping mechanism inside of Kubernetes. Services, pods, replication controllers, and volumes can easily cooperate within a namespace, but the namespace provides a degree of isolation from the other parts of the cluster. Together with her new friends, Phippy sailed the seas on Captain Kubi's great boat. She had many grand adventures, but most importantly, Phippy had found her home. And so Phippy lived happily ever after. The end.
All right. So thank you for watching. All right. So this is a very good illustration on the concept of the Kubernetes service, right? And in how the namespace isolate the port, right? The services, the volume, right, from the other, right? And provide a security on top of that, right? So thank you for the person who created this amazing cartoon, right? And also thanks the founder of the Kubernetes service, right? So let's continue. So just now we know what is Kubernetes, right? Then we have to get to know what is Azure Kubernetes service, right? Azure Kubernetes service is a robust and cost-effective container orchestration service that helps users to deploy and manage containerized application rapidly, right? Where additional resources are assigned automatically without the headaches of managing the additional services, right? So Azure Kubernetes service is basically the Kubernetes service that created by Microsoft, right? So it's built by Microsoft, and it's built on the conceptual mechanism of the Kubernetes engine, right? So on top of that, we also get to know that the other services, how we actually run the Azure, because we know that the Azure Kubernetes service is actually run on Azure, right? And there's another service called Azure Kubernetes service that run on the Azure Stack HCI, right? So Azure Kubernetes service on Azure Stack HCI and Windows Server is an on-premise implementation of the very popular Azure Kubernetes Service Orchestrator, right, with automates the running containerized application and scale it automatically, right? So this is some of the other conceptual about the running the Azure Kubernetes service on the Azure Stack HCI. So I will not walk through all detail of this, right? And you can actually get it while I share the slide deck together and the video in the shared drive later, right? So moving forward, after we know about the conceptual about the Kubernetes service, the Azure Kubernetes service, and also the Azure Kubernetes service that run on top of the Azure Stack HCI, right? So now I wanted to share some about the container registry, right? So what is container registry? Container registry is a single place for you and your team, of course, to manage the Docker image, right? The container, right? It's a place for you to store the container, and it allowing you to upload and download, right? When upload, we call push, right? Download we call pull, right? So this is how we actually by using the Docker command or even using the Docker manager or the Docker other Docker application. While it actually interact with the container registry, it will actually issue a push or pull command, which is uploading and downloading the image from the storage. Right? So this storage is called container registry. Right? So on top of that, there's few types of container registry. Okay. So there is first of it is of course the public. The type of the container registry, one of it is called public type. Right? So the public container registry are the commonly used by the individual or team that want to get up and get there and running their registry as quick as possible. Right? Some of the famous public container registry is like Microsoft, Docker. This is an Kubernetes IO. This is some of the very famous public container registry, right? And on top of that, there's another type of container registry called private container registry. Right? Private container registry provide a way to incorporate security and privacy into enterprise container image storage, right? Either hosted remotely or on-prem. Right? So in order for Docker command or even the Docker application, right, to talk with the private container registry, you need to provide an authentication, right, or core service principal, right, in order for you to access the image actually stored in the container registry. Right? So this is the difference between the public and the private container registry. And on top of that, we can also run the private container registry locally, right? For my own definition, I call it local container registry, right? So this is how we actually store, right? Upload and download the image, right? Without relying on external services, right? So I can actually run this so-called local container registry completely offline, right? And allowing my Docker service, right, the Docker manager, or even the Kubernetes service, right, to talk with it and to ask to push or even to pull down the image from it. Right? So this is a local container registry that I have in the lab environment or the setup environment. Right? So I created some simple illustration on how the local container registry actually works. Right? As an example here, you can see I have an administrator machine. Hold on. Right, so I have an administrator machine. Right, so this machine is responsible to talk with the public container registry, right, and download the container image, right, that I want. Right, so once I download, the container image will actually stop in this administrative machine, right? So for example, it's my administrator machine, right? So I will download the container image that I want, for example, the Windows Server core image, even the Ubuntu image, or some kind of SQL Server image, right? I can download them directly from the public container registry and store in my machine locally here. And after that, I will issue a tagging command to tag the downloaded image in become my private image, right? Local stored container image, and I will push it over to my local container registry for storing purpose, and also get ready for other services to pull from it, right? So once the container image is properly being tagged, right, and push it over to the local container registry, so it's ready to serve the other services, right? Like the Azure Kubernetes service, or even to serve the developer who want a particular image. Right? Instead of for them to go directly to the public container registry, they can actually look for the local container registry, right, for the image download, right, which provide a scenario where in some of the environment, right, they do the Azure Kubernetes service and also the developer machine does not have the direct internet connection, right, to the outside world for them to communicate the public container repository, right? So the only way that they get the image is by contacting the local container registry. And where does all this container image come from, right? So it have to come from a machine. In this scenario, is my administrator machine, where helping all of them to download the image first and tag them properly and push them over and store it in the local container registry, right? And once it's ready, they will actually do some configuration and actually pull the required image, right, from this local container registry, right? So once the image is pulled over, right, and it's ready for the application to run, right? And of course, based on the container image that you pull over, right? For example, you can run the .NET application, right? You can also run the SQL Server, right? For example, right? So in this example, for example, the administrator will actually pull out the SQL Server container, right, from Microsoft repository and push it over to the local container registry. So as long as the developer want to have a container which contain the SQL Server, right, he or she can actually talk to the local container registry and download from here directly, right? So where the container is actually virtualize the whole operating system environment, right? The developer no need to install the whole environment in order to get the SQL Server, right? As simple as downloading the SQL container, and it will able to have an environment with the SQL Server running, and for the developer to inject, right, the application that will actually work closely with the SQL Server, right? So, any point? I think this is a very, very good scenario on explaining how this local container registry will actually help to speed up the image, the container image management, right? Because it's actually pulled from a local container registry, so the speed is very good and very fast, right? For me to pull a 8 gig .NET container registry from a local container registry, right? It takes about a couple of minutes only, and it's very fast, right? Instead of I pulling the whole 8 gig image from internet, and it actually takes longest time. All right. So any question on this area?
Oh,
That's good, huh?
oh,
Yes.
can you hear me? If they say
Your sound was very soft, huh?
very soft.
Yeah, very soft.
Give me a while, yeah.
All right. You need to increase your volume. Yes. How can I help you?
Can you hear me now?
Yes. Now I can.
Okay. Basically, I want to ask, right, because actually is the Docker container actually require the authentication to get an image or not?
For private registry, yes, you have to authenticate first before you can get the registry.
Okay.
Before you can get the image. But for some public container registry, it won't require you to authenticate.
Okay. So if they say the local container, what kind of the authentication they require? Is it AD?
Okay, you have a choice, right? So you are talking about how you actually authenticate with the local container registry, right?
Yep.
Okay, there's a few ways of doing authentication, right? And for my R&D purpose, I actually turn off the authentication.
Okay.
Right, for easier or for the Docker manager to communicate with the local registry. Then, of course, you can actually enable the password authentication, as well as a secure certificate authentication.
Okay.
So there's a couple of types of authentication that enable you to communicate with the local container registry. Right. So the password authentication is a Linux base of password authentication.
All right.
So once the password is created, they will store in the local container registry. It is an encrypted password file, right? And is using the authentication method where normally the Unix system will use, right? And the other type of the authentication is by using the secure socket layer certificate.
So this
okay.
So this is a two type lah, right?
Yeah, basically there's two types. And for secure socket layer certificate, right, they even have two different types, right? You can have a self-signed certificate, which is the certificate is generated by the local container registry engine itself, and you have to export and import it into all the machines that want to talk and connect to the local container registry, right? So if you are using the public public authorized certificate from the trusted CA, then you won't have this problem because it's already trusted.
Yep.
So it will be connecting directly.
Okay.
All right. So hopefully this answers your question.
Yep. All right. Thanks.
No problem. All right. Let's continue. I turn on my pointer. Okay. All right. So let's talk about the manageability of the Kubernetes service, especially in this Azure Kubernetes services, right? So one of the most exciting areas that Azure has been providing for, by the increasing number of customers in Kubernetes, right? The Azure version of Kubernetes service is called AKS, right? As what we saw just now from the conceptual explanation, right? The AKS is Azure Kubernetes Service, right? So when Microsoft introduced AKS in Azure, actually many customers ask for the AKS to be available on premise, right? So in the customer on data center, of course, right? So last year, actually in year 2021, right, Microsoft have met that expectation, right, by coming out a solution where you can actually run the AKS on the Azure Stack HCI, right? So thanks to the Windows Admin Center, where it's a management tool that Microsoft created to manage the Azure Stack HCI. And it is also the tools that will help us to get started with Azure Kubernetes Service. And it is also the tools that connecting us to Azure Hybrid and link to Azure Arc. Right? And from here, I'm going to take you through to what the AKS that Microsoft has created for Azure, and which is now available to customer on Azure Stack HCI running on premise, right? So this is how it works, right? So in my demo later, I'm going to show you how the AKS running on Azure Stack HCI will help you manage the Kubernetes resources, such as namespace, a workload, services, the storage, and the configuration as well. Right? In addition to that, with the Azure Arc capability, right, this management capability has been made available, right, in Azure portal as well. Right? So let me go through a demo recording with you. All right. So Azure actually offered a great control plan using the Azure Resource Manager to manage all the Azure resources, right? By onboarding my AKS cluster to Azure with Azure Arc, I can use the Azure Resource Manager to manage and monitor its security posture, right? Security resource utilization, and of course the configuration and the operation, right? So in my case, I already onboarded my AKS cluster into the Azure Arc, right, using the Windows Admin Center. So let's have a look here, right? So this AKS cluster, for example, right, you can see here the cluster actually become a native Azure resources, even though the cluster and all the data is stored on premise. you can actually get the object in the Azure Resource Manager, and you can see here it's part of the Azure Resource Group as well, right? So first of all, let's I want to show you here is a security center, right? So now it's been rebranded as Microsoft Defender for Cloud, right? So how does this Azure Defender for Cloud actually monitoring the security posture of my the Azure Kubernetes cluster, right? So it will provide the overall secure score and the security posture of my cluster, and to provide additional recommendation, right? And of course, it also provide a way to actually how to improve your security, right? By increasing the secure score, right? And secondly, right, we want to take a look on the policy menu, right, by clicking on the Azure policy, right? So let's take a look on my Azure cluster compliance stage, right? And you can see here that I got one compliance stage which is not compliant, right? So I can actually click on it, right, and see why it's not compliant, right? And I can also see that my Node 1 actually not really compliant with few of the policy. And if I click on the bit, I can actually get to know more in detail, and also the guidance on how can I actually improve and make it to be compliant. Right? So this is how the Azure policy actually work by auditing my AKS cluster. Right? So moving forward, we take a look on the log analytic menu. We can enable the log analytic feature for the specific cluster, and that will send, for example, the event log data to the log analytic workspace, and then we can run query to actually go through and filter the event log for certain event. Right? So as shown, this is one of the very simple query where show all the logs for event, and you can browse through it for checking purpose. I can also go for a performance data query template, for example. There is a query template here we can use, right? So you can go through the template that you're looking for, right? For example, here I wanted to search for the memory usage of my AKS cluster, right? So by running it, I can actually get an overview of how does my memory usage actually with this defined period of time, right, for my cluster. So this is how the log analytic workspace will actually help us to actually monitoring the cluster, right? So speaking of performance data, what can I also do is I can actually use the Azure Monitor, for example, to have a look on the cluster section for the node, right? On the CPU utilization, the memory utilization, the node count, the active node count over a period of time. How does the node count actually been created or it been turned down, right? Because you can scale up and scale down the control plane and the worker node, right? What I like the most is I can actually set a monitoring and view the monitoring for a period of time, right? So in addition to that, I can also monitor the resources utilization for my individual worker node, for example, and the controller as well, and also the container that has been spin up on my cluster. Right? So this is very powerful tools where I can actually have a GUI interface to manage all these objects via this Azure app. Right? While this Azure Kubernetes cluster is actually running on the Azure Stack HCI on-premise. Right? Last but not least, right, I wanted to show you the Kubernetes resource panel, which is currently in preview for Azure Kubernetes Service. And in this panel, I can have an overview. Let me pause here. For here, I can have an overview of namespace. For example, this namespace is actually very interesting. Right? It's actually the namespace that is currently running on my AKS cluster. For example, the Azure Arc namespace is running at the moment. right? And I have the monitoring namespace as well, because I have turned on the log monitoring capability in my AKS cluster called Prometheus. Right? So I will have this namespace created. And of course, I have the default namespace and other namespace that is used by the system. Right? And on top of that, we also have a extension to monitor all the workloads. Right? Right? So the workload is the location where we can actually view all the spin up pods, right? The pod actually contain the container and the application that I started, right? The one I spin up, right? And of course, we have extension for services, right? So just like what the movie showed just now, right? The services is the one who handling all the traffic, right, for the pods and the namespace, right? As you can see here, I have different services that is running, and it actually binded with different IP address, and this IP address it provide a bridge, right, for different services to communicate with each other, right? So this is the purpose of services, right? And after that, we actually have storage, right? And here, the time that I doing this recording, I haven't turned on the log services, right? So if I turn on the log services, there is will be a store. There is will be a storage has been provisioned for log purpose, right? And from here, oh sorry. And this one is a configuration extension, right? Configuration extension enabling you to view and to take a look on about the configuration file of your AKS cluster and also your AKS services, right? So without this, you have to type a certain command in your AKS cluster in order to get all this information, right? But with this Kubernetes resource management panel, I can have all these viewed and shot in a GUI environment, right? And from here, I wanted to show you as well how I actually spin up a container by using a GUI mod, right? Normally, in order for us to spin up an application or a container, we actually use configuration file, init file, right? We normally call it YAM file, right? YAM. And this is a file where actually pointing the location where the image is located, and also the parameter that for you to spin up the application, right? And normally we need to issue a Kubernetes control program to spin up this application by using the YAM file. But with this Kubernetes resource management panel, right, and this workload extension, I can actually spin up the application via this interface, right? So let's take a look, right? So I'm at the workloads extension, right? So what I need to do is I will go to A, right? And by clicking the add, I will actually provide the detail of my YAM file, right? For example, here, I'm actually spin up a Microsoft testing container apps called Azure Vault, right? This is a testing container that provided by Microsoft, right? Normally, we will actually run this for the AKS cluster in the Azure Stack HCI environment by using the command prompt. Right? We do not have a GUI interface to run that. Right? But with the capability of Azure Arc, together with this Kubernetes resource management panel, I actually have a GUI interface to actually spin up the application, right? By putting the content of the YAM file into this panel and click add, and it will actually spin out the container for me. Right? This is something very interesting. last time we only able to run it from the command shell by using the PowerShell and interact with the kubectl command. Right? But with this extension, we can actually spin out the container with a GUI interface. Right? It's very good. Right? So once I provide the parameter file, right, and the AKS cluster will start to spin up the container. Right? So as you can see here, oh, it's very small. You can see here, the container is up and running. Right? So the container consists of two different, the application consists of two different containers. Right? One is called the front end, and the other one is called the back end. Right? The front end is a web page, and the back end is actually the database. Right? So as you can see here, the container is up and running. I can go to the services extension to see what is the IP address that is being assigned to my container. As you can see here, this is actually the local IP address that is running in my on-prem environment, right? Where I actually manage it from Azure portal, right? So this is the IP address that assigned to the application that I spin up. So I can access this interface by using the web browser, and ta-da! So this is the application that I spin up just now. Right? So this is how powerful it is by onboarding the AKS cluster into the Azure app and leveraging the Kubernetes resource management panel. I can actually spin up the container with a GUI interface, right? And it's actually via the Azure portal, right? Any questions so far? All right. So without any question, I got a question to ask. All right. So after you see my demo just now, so there is a simple question to ask. All right. So which of the following extension not provided by AKS resource management? Yeah, feel free to try it out. What is the answer for this? Which extension is not provided by the AKS resource management panel? Is it A, namespace workload, services, storage, or role and feature? Okay, I think VK get it right. So roles and feature is not part of the extension that provided by the Kubernetes resource management panel. Right? So the correct answer is actually namespace, workloads, services, storage, and configuration. Right? So on top, speaking to that, I also wanted to share with you how, let's say, if I want to do all these 5 different segments on-prem, right, by using the PowerShell, right, with the AKS command, how would it look like, right? Because just now the one I show you is actually the one that actually provided by the Kubernetes resource management panel, right? With the interesting and amazing extension, we have a GUI environment to manage and monitor the AKS environment, right? So before that, all these have to be done via the PowerShell, right? So this is the example that I wanted to show you, right? So for example, the namespace, right? This is what you have just now, right? Right. This is the one at the on the Kubernetes resource management panel. And before this, I have to run the command, and it looks like this, right? To show all the namespace that is available in my AKS cluster. And you see that it's actually the same. Just like this is a command base, and this is a GUI base. All right. So let's move forward. How about the workload? Right. So this is how it looks like. Right. In Azure portal, right? In this Kubernetes resource management panel, the workload looks something like this. Right. Easy to read, right? But if you run the same command from the PowerShell, it will be something like this. Right? Not easy to read. All right. So what about other 3 extensions like services? All right. and this is how the services look like, right? And this is how the services look like when you run the same the command with the same capability to list out all the services that is currently running, right? And after that, the storage, this is the one I wanted to show you just now, where it's not available in my demo recording, because I turned it on after I did the demo, the recording, right? So this is how I turn on the Prometheus log management capability, right? So it will provision storage in the AKS cluster, and it will be shown in the resource management panel. And if I want to show the same menu, same information from the PowerShell, and this is what I get, right? So it's actually the same thing, right? And of course, the configuration, sorry, in Azure, it is kind of very easy to read on which kind of information you want to, which kind of configuration, which configuration you want to check. It's very simple to know. But if you are running the same scenario in a command prompt, it's not so easy to read. All right. So this is the difference between the same outcome, but it's from a different tools. All right. One is from the Azure with the Kubernetes resource management capability, and one is from PowerShell. Any questions so far? If not, I will walk you through on some of the management capability by using the Windows Admin Center. All right. So this is how it looks like if I using the Windows Admin Center to manage the resources of this Azure Kubernetes service. Right. So I got a simple demo recording. Right. So this is Windows Admin Center. So once I click on the cluster and I click on the virtual machine, because all the AKS resources is actually a virtual machine. Right? So I can manage all of them, right, from the virtual machine extension here. Right? I can see whether they actually utilize how much memory that is being utilized, whether it's overloaded, right? Whether the CPU is actually overused, whether the memory is overused. I can have an overview of all of them from this virtual machine extension. Right? So you can also have a summary on the overall performance and the utilization detail from this menu as well. So this is how we actually use the Windows Admin Center to manage the AKS environment. Right? So let's move forward. What if I don't like to use Windows Admin Center? I prefer to have other third-party tools. Yes, there is an option, right? You can actually work by achieving the similar capability. Even you can actually customize the dashboard by using the Grafana tools, right? And Grafana need to work together with some of the log metrics, the log collection engine. In this scenario, I'm actually using the built-in, the default log engine called Prometheus. Right? So I also show you a demo recording on how I actually use Grafana to interact with the Prometheus. Right? So this is the Prometheus. Sorry, go back again. Right? So this is the Prometheus log engine that you can actually turn on the feature from the AKS cluster. So once you turn on, it actually has a URL for you to connect after you export the port 1990 into the host level, and you can access the log system. Right? Without this, all the AKS cluster log have to view in text mode. Right? Something like you type a command, it will list out all the log for you for view. Right? So this Prometheus is some kind of like an event viewer where you can have all the logs reading in the GUI mode. Right? So after this Prometheus has been turned on, I can actually install the Grafana. Right? and I can have a simple configuration of the Grafana and get the Grafana to communicate with the Prometheus, right? So from here, I can select the, this is so-called a connector, right? The connector is called Prometheus, right? So it will provide a screen for you to enter the parameter where you're actually connecting to the Prometheus, right? So after all this done, with some simple setting, right? Basically just get all done as default, right? And it will run, right? And for the demo purpose, for demo purpose, I actually use some of the built-in template, right? So this is some of the built-in template that is available provided by Grafana, right? By using that, you can have a simple overview of your status of the AKS cluster, right? Right, so this is some of the template provided by the, sorry, this is the dashboard provided by the template, right, the Grafana template, right? So you will say, what if I wanted to create my own dashboard? Yes, you can, right? By going to the new dashboard workspace, you can actually create your own dashboard object, right? For this example, I can actually search for some of the matrix parameter available, right? For this example, I think I actually added the parameter, the performance counter on how many worker nodes that I have, the node count, right? So I added this parameter and it will become a dashboard object, right? And so I can put it aside, and I can add some more, right? Let's say I want to monitor some of the usage, right? So you can always come here to get the metric sample, and you can edit and adjust it nicely, and basically you can actually create a very custom dashboard for your monitoring purpose, right? So this is some of the simple dashboard object that I actually created, right? So by working on it and try to add some more, then you will get a very nice looking dashboard, something like a template that I showed you just now. Then what you need to do is you just need to save the dashboard, but you give it a name, and it will become it will available on the dashboard browsing list, right? So as simple as that, right? So this is how the Grafana actually work closely with the Prometheus logging engine, right? So moving forward, I also wanted to share some of the capability on how we actually running application, right? Due to interest of time, I think this will be the very last portion that I will share, right? In this example, I will actually spin up a container with SQL Server 2019. Right? This is a very up-to-date, I would say, is the latest container image that is available for Microsoft. Previously, with the SQL Server 2017, we have an issue on spinning up in this Azure Kubernetes cluster, which is running on Windows Server 2022. Right? Because the container image is older than the host operating system version, right? So it's not compatible, right? Therefore, it cannot run. Right? With this latest up-to-date version, I can actually run it, right? So I can have my SQL Server, the latest SQL Server 2019, actually run as a container, right? So let's take a look on the demo recording, right? Let's wait. So this is my container registry server, right? So you can see here I have lots of Docker image. So one of it is the SQL Server image that I downloaded. As you can see here, is 1.66 gig, right? So the original, let's see here, green, all right? You can see here, I downloaded from Microsoft, right? And after that, I actually take it and push it to my container registry. Yeah, you can see here. This one. Oh, yeah, not familiar with the tools yet. This one, you can see here, this one is downloaded from Microsoft. Sorry, the upper one is downloaded from Microsoft. This one is from Microsoft. After that, I take it with my on container registry name, right? And I push it over into the local container registry, right? So you can see here the default one is mcr.microsoft.sql server something, and I take it to become my local container registry, and I push it over to my local container registry, right? So this is the image, the container image that now actually sit in my local container registry, right? Then after that, what I need to do is I'll need to change the configuration of the YAML file, right? So as you can see here, the default is actually pointing to Microsoft, right? So I will change it and point it to my local container registry, right? So I already have a copy, which is changed already, right? You see here, my image is actually pointing to my local container registry, right? So just now it's Microsoft. I actually changed it to the image where the location, the image location path is my local container registry, right? So after that, I will issue a command to spin up the container. As you can see here, just now I do the same thing, right? But with a GUI interface. Now I have to do it everything in command prompt, right? So this is how I actually call out the command and spin up the container. You see? So I issue the Kubernetes command, right? Apply. Apply is to spin up something, and this is a init file, the YAML file that contains my parameter as well as the image of my SQL server, right? Once the command executed, right, so you can see here the container is up, right? The container is created, right? So once the container is created, I will actually need to know what is the IP address that is being assigned to the container, right? So what I need to do is I need to actually to get the service, right? So before that, I have to make sure that my image pooling is successful. Right? What you can see here is successful pull the image from the local container, right? So the image pooling from the local container is successful, right? And the container is created, right? And it's up and running, right? So once I know that the port, the image pooling is successful, I will need to issue the service command in order to know what is the IP address that is being assigned to my container. Right? This is for me. I'm actually checking whether the port is up and running, and also the deployment is up and running. Right, and after that, I will issue a get service command, and it will tell me my SQL server. This is my SQL server. It's running, up and running, right, with the load balancer, and this is the IP address that is being assigned, right? Let me see. Okay, the IP address is being assigned, right? So this is the IP address that assigned to my SQL Server container, right? So what I need to do is I just need to knock down this IP address, and I opens up my SQL Server. This is what is this name already? Management Studio, SQL Server Management Studio. All right. With the IP address and also the port, I can actually interact with the SQL Server. which is actually running inside my container, right? So as you can see here in the property, right? This is a SQL Server, 64-bit edition, and is actually running on Ubuntu. Right? Yeah, see? Yeah, so this is a SQL Server that's running inside a container. And now I'm actually spin up the container and I get the SQL Server capability. Right? So this is a very good scenario where if a developer, they has developed an application that need to interact with the database, and he or she need to build an environment to install a SQL Server and perform all the configuration parameter, everything, just to get the SQL Server up and running for the application to connect, right? But in this scenario, what it need to do is just to spin up a container with a SQL Server inside. Then he or she can actually start and to get the application work with the container with the SQL Server ready. Right? So this is how powerful is it. The container, the containerization capability for developer perspective. Right? So once the SQL Server is up and running, right, I can actually interact with it by passing some simple parameter to create a database, create a table, right? Just like a normal database, right? The only difference is this SQL Server is actually running inside a container, right? So this is how I interact with the SQL Server that is running, as same as interacting with the SQL Server that running in any machine, right? So due to interest of time, I think that's all for me today. So far, any question?
No, for me.
Very good. All right, so this is how I spin out the container, and this is some other topics where I actually shared how to install the Kubernetes service. All right. I will share this video into the internet where all of you can view it later. Right? So this is how the Kubernetes service is installed by using the Windows Admin Center. And of course, you can also install to turn on the AKS by using the PowerShell. Right? And this is how we actually configure the AKS cluster. Right? And of course, you can do it with the PowerShell as well. Right? And of course, the patching of the AKS services using the Windows Admin Center. Right? So this is pretty simple. You just go to the Windows Admin Center and click on the setting. Right? So as long as there is a newer version here, you just click and update. Let me see this I have or not. Oh, this one no update available. It's latest version already. Right? And of course, you can perform the update by using the PowerShell as well. Right? And this is how I interact with the control plan as well as the worker node by using the command prompt. Right? And this is how we actually using the Windows Admin Center to manage the resources. Right? And this is by using the Kubernetes panel that is provided by Azure. Right? All right. So I think that's all for me. This is some of the reading material. Any questions so far? If not, I think I'm going to stop here. All right. And feel free to drop your comments into the form, the feedback form that I actually paste into the chat window. Right? And we'll see you again next time while I actually compiling on the new series of sharing on this Azure Kubernetes service, right? And looking forward for it, and see you soon on the next part of the sharing. I think maybe in June or July. All right. So see you again, and thanks for joining, and good night.
Thank you, Cole.
Yeah, no problem. Thank you.
Thanks, Cole.
All right. See you. Thank you. Thanks for joining.
Good night.
Good night.
Night.
All right. Thanks.
Thank you.
Thank you. Thanks, Ivan.